Hi guys, I've kind of tried to style up this thread and see how it went for everybody participating. Um, and it looks like some people came up with some creative ways to get this thing drawn. Um, I would have gone about it a little bit differently. As I said, there's always two or three ways to do something in Design Edge. But once the solution was posted, um, I look and I think there's some inaccuracy, and I want to address that. In fact, it's obvious when that first radius was made in the example to round the end, when that circle overlapped and had to be trimmed off separately, that is the indicator that it is not the correct size to radius the end. And it all comes down to drawing a circle that is tangential to two different line segments. So we're kind of back in fuddling about in geometry because you have to bisect an angle to get it accurate. You cannot use the orthogonal snap unless the lines are parallel. Because you'd be bisecting a 90-degree angle if they were parallel, but they are not parallel in this example. They're slightly off. So let's just start with the basic shape, and I'm going to give you a quick example and show the error, and then go ahead and correct it for you so you could see how to draw this correctly. So we're 6.593 tall, 23.277 long. So much similar, 6.593. I'm going to do L for line, anchor it, and then I'm going to say at 0, 6.593 and hit enter. And then I'm going to focus on that angle, which is 84.98, and get that in there first. So to do that, I don't have to stop. I can just do an angle, and then I need to rotate clockwise, so that's in the negative direction. So I'll put a negative, and then I'm going to put a parenthesis to do a little math and say 90 minus 84.58, since that is the angle that we were given. Oh, excuse me, 84.98. And then close that parenthesis, and then comma, and then I need to put in a distance, so I'll put 30 and let it go out there. And so now then you can see, if I unclick, I can Control D and see that we are at 84.98. And then I can K break this at that node so that I can, just like you were shown in the example, I for mirror, M for midpoint, and I'll just mirror that about that midpoint and use the O orthogonal snap. Hold Control, and there it is. Now for the length, we were at 23.277, so I'll push O for offset, 23.277, enter. Then I'm just going to hold Control, and that'll plop that down there where we need it. And then I can X trim this all off. Right click, and then J for joining it up. So this is control dimension is M midpoint. There's our correct length. Node to node here, 6.593. We'll double check. All correct. There. Now then, in the example you were given, there was an orthogonal line from this connected those midpoints. And then the instruction was to line E endpoint and then orthogonal up, and then a line from that I intersection down P perpendicular to come up with a circle to fit in that. And that would be correct if this line were what we were trying to come to tangential to. But it's not. It's this angled line. So what we have to do is bisect that angle. But before I do that, I want to do one other thing. And that is, I'm going to go ahead and get this done the way it was previously shown. I'm going to copy this up here. And then I'm going to Q from this E endpoint to that E endpoint. And then we can see the problem is it doesn't fit. But the instruction was to trim it off. So I'm going to trim it off just like that. And then I'm going to join it up. And then I forget how he did the first circle, but I'm just going to Q, C center point, E end point or quadrant again, then offset 0.5 enter to put that in the 1/2 inch. So I don't remember if that's how that was done or not, but O offset 1 inch as we were told, hold control, and then we were making a Q and we were moving it from this quadrant to that quadrant, and then we got rid of that, and then we drew a line from that intersection orthogonal up like that, and then I think he scaled this circle from that endpoint or quadrant and that intersection up to that intersection. And so, as you can see, oh shoot, it won't work if I don't offset that 0.5. So line, intersection, orthogonal, scale, endpoint, intersection, intersection. So there we are back where we were. But here's the problem. That doesn't really do it. Because if you zoom in, all we're doing is duplicating the same problem that we had on the first circle, which is that they are not tangential. So let me get this out of the way. So if I do a Control D for a dimension, Q quadrant to a P perpendicular, then it is 0.5. But the problem is, that is not to say that the tangential line that crosses those is 0.5. So I'll L line T tangent, and then I Control D for the dimension, H for on that path, P for perpendicular, and you can see that I only really have 0.495 because the circle is too big, just like the one that was too big to go around the end. And so that's the trouble I have with that method. So let's pull this one back down in here and try the correct way, which would be to bisect this angle. Control D, click and click. That's 95.02, which we just defined it down there. It's 84.98. And so all we need to do is now bisect that angle, which means to cut it in half. So I could find that rotational angle over here, but it's not worth the trouble. I'm going to do L line from this end node point, orthogonal, down straight with it. And then I'm going to rotate it half of that angle, which is 95.02. So I'm going to R rotate from the E end point. And then I'm going to go ahead and do the math here, which is, do I want to go clockwise or counterclockwise? The answer is clockwise. And to get that out here, out into the middle of this angle. So clockwise is negative in design edge and in all geometry and anything that uses Cartesian coordinates. So negative, and then I'll do a parenthesis to do my math, which is 95.02/2, or divided by 2, and close that parenthesis and hit enter. And so what I've done is bisect that angle so that I have equal angles on each side. Now, this angle remains constant, so I'm going to copy this and put it over here to use that later, so that I don't accidentally lose it. And then I'm going to go ahead and put a line from this midpoint orthogonal. I don't, because I need this intersection point. So now I can do a Q circle from this I intersection to this E endpoint. And now look what happens. When we use a bisected angle to find the center, it's actually tangential. So that is touching. If I'd selected in D for detect intersections, you can see that there's one intersection at each place it touches. So now I can get rid of these lines for a moment, and I can X trim that off, and then J, and see how it all joins up the way it's supposed to. Now to get my first circle, I can Q from the C center of that arc, which is my outside, and then I can Q quadrant so that it is exactly on top of it, and I can offset it at 0.5. Hit enter, and that'll be my first circle, and that is a 1/2 inch in all the way around. And so then now all I need to do is find this next section. So I'm going to put this line from the midpoint to this quadrant in again, so it's ortho, and I'm going to now draw myself a line perpendicular to that, because that's the dimension from quadrant to quadrant. Here is the farthest, so M move M midpoint, Q quadrant, and I'll snap it right there. And then I'll just push O offset, 1 enter, and that'll pop that over an inch to give me an inch spacing. Then I'm going to offset this whole thing in a 1/2 inch, just like was done in the past in the example, and that is again just a reference point. So I'm going to X extend that up there. Then I'm going to get my angle back over here again. I'm going to C copy from the E end point to this E end point. And wherever that angled line that bisects it, cuts that orthogonal line to make that next radius is correct. So I can Q from I intersection to I intersection, and there is a tangential circle. So I'll delete that out of the way, and I can just M move, M midpoint, I intersection. It'll pop it right there, offset 1 enter. That pops it over an inch for me. I can extend it up. And then I can copy this from the E end point to this end point, Q, I intersection, and we have another one. Delete, M move, M midpoint, Q for quadrant, doesn't matter which one you use, offset 1 enter, click, extend, and this time it's going to be in the way, so I'll M move from its E end point to the E end point, Q, I intersection, then I can move this from M midpoint to Q quadrant, clicking on the circle, offset 1 enter again. This is 1, 2, 3, 4, this is the last circle. I'll extend that. I'll move, M move, E end point, Q, I intersection. Then I can delete all my reference lines out of the way. Now when I look at this, if I draw myself a dimension from this Q quadrant to this P perpendicular to the outside, then it's not 0.5. It's bigger than 0.5 because I'm not measuring. See how my dimension line goes inside that hole? So what I really need to do to find that dimension is draw me a reference line that is T-tangent. Doesn't matter which one of these circles you pick, T-tangent is going to touch all of them. And I can do now Control D for dimension, H on this path to P perpendicular on that path, and now I have a true 0.5 inch spacing around the outside, which I think was the real challenge in the drawing. I think that dimension was probably just inaccurately assumed to be from that quadrant to the outside what would be the closest, but it is in fact not. So this would be my submission, that the correct way to draw it would be to use the bisection of an angle to find where you need to draw a circle that is tangent to both lines. And I think that will give you the desired result. So hopefully that is helpful, and it's good talking with you.